Hello, good morning, everybody. Today, let's see how to write an assembly program for 8051 microcontroller. So, so I am using an AS31 assembler. Okay, this is an 8051 assembler from PRJC, and the options this program is used to assemble the assembly program mnemonics and create an X file. Some of the options supported by this assembler is -L to create a list file, -S to output the hexadecimal or the X file into the standard output. Or if you want to generate a X file, then you don't use this -S option. Then the output format that we want to generate -F, and this is the default Intel X file. And if you want the optional output formats, additional output formats, you can have -A option. We provide one of the formats here. So an example usage is, so this one AS31 -L option to generate the list file, -F option and X to generate the X file. And then comes your actual assembly file. So just create your assembly source file, just a ASCII text file here. And then you create a assembly code. Okay, first what I'm doing is I'm creating a symbol for the base address of my code memory. So actually I'm using a single board computer for 8051. So where the external memory is mapped at address 8000X, it is an external RAM, and the single board computer contains a Pullman to monitor program, which runs in from the internal flash of the 8052 microcontroller. Okay, so that gives me many options to download the code and run. We'll see that in short time. So then to start with the program, you have to use the .org directive with the argument as a base code address that is 8000. So all your assembly instruction that follows this directive will be placed starting from address 8000. Okay. So I have written a small program to add two numbers and store the result in the external memory at address 9000. So I am loading this 9000 value address value into data pointer register. Then I'm taking the first operand into A register and second operand into R0 register. Then I'm adding these two operands and storing the result into A register. Then I'm using MOVX instruction to move the result in A register into the address pointed by this data pointer. And finally, I'm jumping to this fixed address. Okay, this address is belongs to the monitor program, so the control jumps back to the monitor program. Okay, and then the dot end directive indicating the assembler that this is the end of the assembly program. Save it. Let's assemble this program. So here I've already added my assembler in the Windows environment path, and I've launched this assembler from, and this is my current working directory, okay, where my assembly program is stored. This, so I'm launching assembler from this uh, working directory where my ASM program is present. Okay, there are no errors, so both are passed. Now my output is generated X file. Okay, this is my X file, and there's a list file as well generated. You can see that. So this is my actual assembly code, and in the list file you can see the address as well as the machine codes for each and every instruction. Now to test this program, I'm using a hyperterminal or teraterm. It's a terminal program. So this program communicates with the single board computer to the UART port. Okay, and it runs at So yeah, my COM port is at COM4 in my laptop, and the baud rate is 9600 with 8-bit data. Now parity 1 stop bits. You see, this is my prompt coming from the monitor program. So you can see the supported commands by typing a question mark. That is kind of help. So it has all of these commands. And to run the program, first we need to download, that is D. Then we have to use J, that is to jump to the memory location. And it executes all the instructions starting from the jump address. Okay. And you can view the content of external memory using H and internal memory using I. And you can also edit the memory contents using E command. That's external memory. You won't be able to edit the internal memory because that contains certain values belonging to the monitor program, so which you don't want to corrupt. And you can also clear the memory, and this is also for the external memory. And there are additional commands to list the readily available programs. Unless, and there is a list command as well. So this is kind of a disassembler. So it will read the machine code out of the code memory and print here in this console as a assembly mnemonics. You'll see that. Okay. Let's say go to the 8000 location by typing this new location command. So my prompt is at 8000 location. Now let me download by pressing D command. Go here, file, and send the X file. So it has downloaded the program, no error. Now let's type list command. So you can see the list command prints the assembly instruction start and disassembles the instruction starting from 8000 address. That is my current address pointed by the monitor program. You can see the instructions are corresponding to my code. Okay. According to this. Now let's run that program. So say jump and you type my org address, that is 8000. Yeah, now the program has run. Accumulator is A5. You can conclude from here. So just before moving to the external memory location, the result is placed in accumulator, which is A5. So my first operand is A0. My second operand is A05. And when you add it, the result A5 will be in accumulator. That's what is printed here. Now let's view the external memory. For that, you have to type H command. So before that, we will go to 9000 location. Now type H. Yeah, so it dumps the memory 256 bytes starting from address 9000. And you can see at 9000, I have A5, the result. Okay. Yeah, hope you like this video and it helped you learn something new. Thank you. And if you like this video, please support me by subscribing to my channel and give a like and yeah, press the notification bell as well. So you will get notification when I post some new videos. Thank you. Bye.